The Application Builder, included in COMSOL Multiphysics version 5.0 and newer, facilitates the creation of specialized apps from COMSOL Multiphysics models that can be used by anyone. Great for simulation engineers that want to share their models with a wider audience. Through 3 industrial demo apps, we will introduce you to the form editor, form objects, and the method editor, and demonstrate how you can edit parts of the app yourself. Our first demonstration features the Heatsink with Fins app, which would be useful in the electronics cooling industry. In this model, an airflow passes through the channel and cools off the aluminum fins which are in contact with a heat source. Now, looking at this app, we have inputs where I can change the geometry, such as the fin height and the number of fins. And I have operating condition inputs where I can change the inlet velocity, temperature, and the heat source temperature. And then I have results, some information on the expected computation time, and I can also send an email message when the model is computed. I also have the graphics section, which shows the geometry, the mesh, the temperature, and the velocity. And now that I've changed the input data, I can update the geometry, and I can remesh this model. And after this, I could compute my model. So let's take a look in the model to see how this app was created. The app shown was built after this model had already been created in COMSOL Multiphysics, as we can see here in the model builder. We have the material properties specified, the physics boundary conditions applied, the study step has been added, and the results plots have been customized. The application builder is fully integrated in COMSOL Multiphysics. As you can see here, it has its own section in the Home tab. When I click the Application Builder button, I stay within the same window, but now I'm in the Application Builder. So let's take a look at the basic structure of this app here. The 2 main app building tools are forms and methods, and we will start by looking at forms, which are the platforms on which your app is built. We have the main form open, and it looks a lot like the app interface that we saw before, because it is the reference form for the main window. So that means that this will be the first form that is shown when we open our app. To maintain an organized structure, this main window has text labels for the input and results and graphics titles, and form collections, which are containers that hold other forms. This first collection holds 5 other forms for the geometry input, operating conditions, results, information, and the email message. The second form collection holds all of our graphics windows. All of those forms referenced are here in the form editor, and we can open them and take a look. Now let's say I wanted to add a pressure graphics plot to my app. I can add a new form and select the graphics plot for pressure, and then click OK. And my new form has been created. Now I can rename this, and I'll rename it graphics underscore results underscore pressure, and then we'll have the title as pressure. So here I've created my graphics form. Then when I go back into the main form, I can go to my second form collection and add the graphics results pressure plot. Finally, I can test the application, and here I have my pressure plot. This next app, which analyzes the payload capacity of a truck-mounted crane, uses a wide variety of form objects and is a bit more interactive. There are these sliders, which update parameters based on a given range, and an image here that shows us how each slider affects the configuration, and a legend detailing the different parts of the crane. There's a button to update the configuration of the crane in the graphics window, and input fields to change the capacity of the cylinders, as well as an input field for the weight. Finally, the results determine what the payload capacity will be, as well as the usage of the hydraulic cylinders. So let's take a look at the different form objects used in this app. The main form is again filled with text labels and collections, but if we go into the orientation and extension form, there are text labels, equations, input fields, units, sliders, and a button. And then in the sketch form is where we have our image, and we actually have another image here. The results form has a data display and a card stack. All of these objects are added using the Insert Object button, and learning how to implement and use these different objects is beyond the scope of this video, but you can learn more about them in the instruction manual. Changing the layout of an app can be important when customizing it for different users, and that's why Sketch Mode is a really great feature. Let's say, for example, your app needs to be much thinner, but you don't care how long it is. With Sketch Mode, you can drag and drop your objects very easily. So here I'm using the Control-click to select multiple objects, and then simply dragging them around the interface. I can delete these vertical lines and move the image over. And scrolling down, I will make my graphics window bigger. Now, when I preview the form, you can see that it's much thinner and a little bit longer. So this is just an example of how you can easily change the layout of your app to match the needs of the people that are using it. To introduce the method editor, we will use the Corrugated Circular Horn Antenna app. In this app, we have an action console to compute the study, preview the geometry, reset parameters, and run a simulation report. We also have a result analysis section that provides specific output data from the simulation. On top of that, there are graphical results for the 2D radiation, 3D radiation, source polarization, and aperture polarization. And here we have design parameters that allows us to adjust a number of the geometric and operational parameters, like the length of the horn. I can use the action console to preview the geometry. And then I can also use this Reset Parameters button and confirm that I want to go back to the default parameters. Let's take a look inside the app. To introduce the method editor, we will look at the Reset Parameters method. In this method, the first line adds the confirmation that asks us if we're sure that we want to reset the parameters. And if we answer yes, all of the model parameters are set to their default values, the geometry is updated, and the status bar notes that the default parameters are reset. Looking at setting all of these model parameters to the default values, let's take a look at an easy way to add this code. Instead of typing it all in, we can use the record code option, which takes us into the model builder in COMSOL Multiphysics, and there's this red box around the user interface. So I can go to the parameters node, and I will change all of these parameters slightly, and as I'm doing so, the code is being recorded into the method editor. After changing these parameters, I can stop recording and go back to the application builder. And here, the code has been recorded inside my if statement. Now, it may look a little different than the original text, but as the saying goes, there's always more than one way to solve a problem. And this is especially true with the method editor and the application builder in general. Now, I can test my application again. And here I will change around some of the parameters, preview the geometry, and then I will reset the parameters again and confirm yes. And here we can see that the parameters have been reset. Hopefully this demonstration has given you a better appreciation for the application builder and opened up some of the possibilities within your engineering discipline.